There is a market in Pozzuoli where the sea once stood. You can walk to it this morning if you like. Down past the harbor where the fishing boats are coming in, past the espresso bars where the machines are already hissing, past the school children in their bright backpacks moving in loose knots along the waterfront. The light on the Bay of Naples at this hour is the color of a peeled apricot. It is one of the most beautiful places on earth to be alive, and almost nobody walking through it is thinking about the ground. But the ground is thinking about them. In the center of that ancient market, there are 3 tall columns of marble still standing. They are Roman. They held up the roof of a building called the Macellum, a food market, nearly 2,000 years ago, and later people mistook it for a temple to the god Serapis, and the wrong name stuck, so most people still call it the Serapio. Look up at those 3 columns. Look about 7 meters off the ground, roughly the height of a 2-story house, and you will see, drilled into the solid marble, a dense band of small round holes. Those holes were made by shellfish, sea creatures, marine borers, the kind that only live underwater, that eat into stone the way woodworm eats into a beam. They cannot survive in air. They cannot climb. They did not carry the marble up there. The marble was down there, submerged under the sea, for long enough that living things colonized it and fed on it and left their signatures behind at a height that today stands well above the waterline. Which means the ground did that. The ground carried those columns down beneath the waves and held them there for centuries, and then lifted them back up into the sunlight, all on its own, without an earthquake anyone recorded as catastrophic, without a mountain exploding, without a single line in the history books that reads, "The day the land rose." It just happened. Slowly. The way a chest rises and falls. That is the first thing to understand about this place, and it is the thing that almost every visitor misses. The land under Pozzuoli is not stable. It has never been stable. It breathes. And right now, tonight, as you read this, it is breathing in. Since the year 2005, the ground at a single point in this city has risen approximately 163.5 centimeters. That is the height of an adult person. Stand up. Look at the top of your own head. The land that 500,000 people live on has climbed that far into the air in the span of a single childhood, and roughly 25.5 centimeters of that, the length of a forearm, has happened just since January of last year. That sounds like nothing at all. Slow ground. Who is afraid of slow ground? The people who study this for a living are afraid of it. Not panicked. Afraid. And there is a difference between those 2 things that this entire story turns on. Because in April of last year, a team of researchers published a paper that changed the way the specialists talk about Campi Phlegrae behind closed doors. For 20 years, the assumption had been that the acceleration was exponential, and exponential is frightening, but exponential is at least familiar. It curves upward forever, without ever arriving anywhere. What the new mathematics suggests instead is something with a harder edge. Not a curve that climbs without limit, but a curve that arrives. A finite time singularity. A process converging, right now, on a specific window of years. That window is somewhere between the year 2030 and the year 2034, which is close, which is very, very close. I am going to show you exactly what that word means, and exactly what it does not mean, in about 10 minutes. And I'm going to be honest with you the whole way through, because there are 2 easy stories to tell about a place like this, and both of them are lies. The first easy story is that 500,000 people are living on a bomb with a lit fuse and a countdown. The second easy story is that the ground has always moved and always will, and everything is fine, and the scientists are just chasing headlines. Neither of those is true. The truth is stranger than both, and I've spent a long time with it, and by the end of tonight, you are going to understand why the people who monitor this caldera cannot sleep and also cannot evacuate, and why those two facts are locked together in a way that has no clean solution. This one is not over. The ground is still rising tonight, the instruments are still writing their lines, and there is no all clear coming this week or this year. So if you want to follow this as it develops, the place to do that is right here. Subscribe, because we are going to be watching this one for a long time. And I have a question for you, a real one, because it is the same question the authorities in Naples are asking themselves in rooms you are about to sit inside. If you were told the ground under your home was rising toward a threshold, and the threshold might be 4 years away, and it might be 40, and it might be never, and leaving means abandoning everything you have and everyone you know on the strength of a curve on a chart, would you go or would you stay? Tell me down below. Tell me honestly. Because that is not a hypothetical to 500,000 people. That is Tuesday. By the time we are done tonight, you will be able to look at a photograph of an ordinary Italian street, a repaved road, a cracked apartment wall, a door frame that does not quite square, and read the volcano in it the way a doctor reads an X-ray. You will understand what the ground sounds like when the pressure moves. You will know the name of the market that drowned twice. And you will understand why the most dangerous thing about this place may not be the eruption everyone fears, but the memory of what happened here the last time the ground did this, and how few people who made the decisions then are still alive to make them now. So hold the image of those columns, the marble scarred by shellfish, 7 meters up in the dry morning air. We are going to come back to them. They are not a ruin, they are a receipt. Now, let me take you back down to the water. The harbor at Pozzuoli in the early morning is a working place, not a postcard, though it happens to be both. The boats come in low in the water with the night's catch, and men with forearms like ship's rope haul plastic crates of silver fish onto the quay. And there is a smell that is salt and diesel and coffee all braided together, and a woman in an apron props open the door of a bar, and the light spills out onto the wet stone. Children pass. A priest passes. A delivery scooter threads between them all, with the casual homicidal grace of every scooter in southern Italy. This is a town of about 80,000 people, ancient beyond ancient, founded by Greek exiles more than 2,500 years ago, a place that was already old when the Romans made it their great western port, and called it Puteoli, and shipped grain and marble and gladiators through it to the whole of the Mediterranean world. And all of it, every stone of it, sits inside a volcano, not on the slopes of one, inside one. That is the part that catches people. When you say the word volcano, the mind reaches for a shape, the cone, the classic mountain with the smoking top, the one that looms over the far side of this very bay and has its own terrible fame. Vesuvius. Everyone knows Vesuvius, but Campi Phlegrae is not a mountain. It is the opposite of a mountain. It is a hole. A vast, sprawling depression in the earth called a caldera, 12 or 13 kilometers across, formed when an enormous volume of magma emptied out from underground in eruption so violent that the roof of the chamber collapsed downward into the void it left behind. The caldera is the scar of that collapse, and over the tens of thousands of years since, people have filled that scar with towns and roads and vineyards and churches and apartment blocks because the soil is rich, because the harbor is good, because the coast is gorgeous, and because human beings will build a life anywhere the ground holds still long enough to lay a foundation. The name, Campi Phlegrae, means the burning fields. The Greeks who named it were not being poetic. They watched the steam rise from the ground here, and they decided this was the place where the gods had thrown down the giants who rebelled against them, and buried them, and that the smoke was the giants breathing. Which is a myth. But you will notice it is not a stupid myth. It is a very precise myth, built by people who observed the same thing you can observe today, which is that the earth here is alive and warm and exhaling. and it is exhaling harder now than it has in a very long time. Walk east from the harbor and you come to the Serapeo, and now you can see the whole story written in one enclosure. The 3 tall columns and their band of shellfish holes at 7 meters. The pavement of the ancient market floor, which has itself gone under the sea and come back more than once, so that at certain periods in the last few hundred years, the ruins stood in standing water, and visitors were rowed through them in small boats, and at other periods they stood high and dry as they do now. There is a 19th century engraving of the Serapeo half-flooded, tourists in a rowboat drifting between the pillars, and there are photographs from the 1980s of the same floor bone, dry and cracked, and the only variable that changed between those 2 images was the ground. Down, up, down, up. The scientists have a word for this. The word is bradycism, and it comes from the Greek, and it means, more or less, slow earthquake. Not the violent slip of a fault in a matter of seconds, but the patient, grinding, years-long rise and fall of an entire landscape as the pressure in the rock beneath it swells and subsides. Bradycism is not unique to Campi Phlegrae, but nowhere on Earth does it perform this trick so dramatically, so visibly, in front of so many people, on top of so much magma, as it does here. The Serapeo is, quite literally, the most famous natural instrument for measuring vertical ground movement in the history of geology. Before there were satellites, before there were GPS benchmarks, there were those columns and the height of the shellfish holes, and a very old lesson written in stone for anyone willing to read it. The lesson is this: you are not standing on the ground. You are standing on the lid of something, and the lid moves. Let me put a face and a set of instruments on all of this, because a number on its own is a ghost, and I promised you the number would become physical before you left tonight. Up on the hill, on the Naples side, there is an institution called the Osservatorio Vesuviano, the Vesuvius Observatory, which is the oldest volcano observatory in the world, founded in the 1840s, and which today is part of Italy's National Institute for Geophysics and Volcanology, the mouthful usually shortened to INGV. This is the body responsible for watching both Vesuvius and Campi Phlegrae, day and night, without pause, forever. And if you sit with one of their volcanologists and ask them to show you what is happening under Pozzuoli, they will not gesture at the sky. They will unroll a chart. The chart is a line. Time runs along the bottom, from 2005 on the left to now on the right. Elevation runs up the side, and the line, which starts low and nearly flat, begins to climb, and the climb steepens, and by the right-hand edge of the paper, it is going up like the side of a hill. That is 163.5 centimeters of climb. That is the ground at a benchmark near the Rione Terra, the ancient acropolis of Pozzuoli, the old rock at the heart of the town, lifting itself the height of a grown human being since the middle of the 2000s, with the sharpest part of the rise crammed into the most recent stretch. And here is the thing that the chart does not show you, that you have to walk the streets to feel. The uplift is everywhere. It is not confined to a laboratory. It is in the fabric of the city, in the ordinary daily surfaces that people touch without thinking. Take that chart and walk down into the old town with it, and you begin to see the second, hidden map laid over the first. There is a crack running up the plaster of an apartment building, thin as a hair at the top, wide as a finger near the door, and the residents have painted over it, and it has come back, and they have painted over it again, and you can count the layers of paint like tree rings, each one an admission and a denial at once. There is a door frame that no longer sits square in its wall, so that the door catches on the tile when you open it, and someone has planed the bottom of the door down to make it fit, and it does not quite fit. There is a street that has been repaved so many times that the new asphalt sits noticeably higher than the doorsteps it was meant to meet, so you step down into shops that once opened level with the road, and the shopkeepers do not remark on it, because you do not remark on the weather, you simply live inside it. None of these things on its own is alarming. A crack is a crack. Old buildings crack. Old streets get repaved. If you had never seen the chart, you would walk right past all of it, the way 500,000 people walk right past all of it every single day, because that is what human beings do. We normalize, we adapt. The ground rises a millimeter, another millimeter, the width of a coin over a month, and no morning ever arrives that is dramatically different from the morning before, and so no morning ever forces the question. That is the mercy of Bradycism, and it is also the trap of it. It is slow enough to ignore. It is precisely, exactly, dangerously slow enough to ignore. But lay the chart over the city, and the cracks stop being separate facts. They become one fact. They become the shape of a whole landscape flexing, the way the skin over a knuckle stretches when you make a fist. The door frames and the repaved streets and the painted-over cracks are all saying the same thing the shellfish holes are saying, only in a modern dialect. The ground is not still. The ground has never been still. And now, the researchers are telling us, the ground is doing something it has not done in the entire span of the historical record, which is accelerating in a way that appears to be converging on a threshold rather than simply climbing without end. The mechanism, as best the science currently understands it, is not what most people imagine. When you say a volcano is waking up, the picture in the mind is molten rock rising, magma climbing toward the surface, getting ready to burst out. And that is not, so far, what the instruments are describing here. What they describe instead is pressure. Deep beneath the caldera, magma is releasing gases and fluids, volatiles, superheated and under enormous force, and those fluids are pushing up into the crust above the magma, pressurizing the rock, inflating it, the way air pressurizes a sealed vessel. The ground is rising not because a mountain of lava is on its way up, but because the rock beneath the town is being squeezed and stretched by pressurized fluid from below. That is a critical distinction, and I am flagging it now, early, deliberately, because it matters enormously later, and I do not want to overstate it, so I will say it as plainly as I can. The uplift does not mean an eruption is imminent. The scientists say this again and again, and they mean it, and they are right to keep saying it. Pressurization is not ascent. A swelling is not a launch. But hold on to that word. Pressure. Fluid pressure in cracked faulted rock, building over 20 years, accelerating in the last one. We are going to need it. Because there is one more thing the specialists say about this current episode, and it is the sentence that took the rest of this out of the realm of routine, and it is short. The current unrest is the longest and one of the most energetic in the historical record. Longest. Most energetic. In the record. Those are not doom-farming words. They are the careful, hedged, understated words of people who spend their lives resisting the urge to overstate, and even in their carefulness, the meaning gets through. Whatever this is, we have not seen its like before. Not at Pozzuoli. Not in the span of time that anyone has been keeping notes. And that is what makes the memory in this town so unbearable. Because the people who live here have seen some of it before. They have a reference point. They have a scar of their own, one that is only 40 years old, still inside living memory, still discussed at kitchen tables. And when you talk to them about the ground rising, they do not think about April's paper, or the singularity, or the year 2030. They think about the 1980s. They think about the last time the ground did this, and about what it cost them. Between roughly 1982 and 1984, Pozzuoli went through the most acute bradyseismic crisis of the modern era, until the one it is going through now. In the space of about 2 years, the ground rose nearly 1.80 meters, and unlike the slow, insidious creep of today, that rise came fast, and it came with earthquakes. Not one great earthquake, but swarms of them, Thousands of small and moderate shocks, more than 16,000 of them recorded across the crisis, day after day. The ground shivering and jolting under the town, plaster falling, walls cracking not over years, but overnight. People running into the streets in their night clothes, the terror not of a single blow, but of the endlessness of it. The sense that the earth had simply decided to stop being still, and no one could say when or whether it would stop again. The harbor rose so much that it became too shallow for ships to dock. Read that again. This is a port city, a port for 2,500 years, and the sea floor lifted so far and so fast that the boats could no longer come in. The town's entire reason for being, its living, its history, its identity, was choking on the risen ground. And so they evacuated. 40,000 people. The historic heart of the town, the Rione Terra, the very rock we have been standing on, that ancient acropolis where people had lived continuously for millennia, was declared unsafe, condemned, emptied. Apartment blocks were cleared and closed. Families who had lived in the same rooms for generations carried what they could and walked out and did not come back. And the district was sealed, and it stayed sealed, a ghost neighborhood on the highest, oldest ground in the city, and much of it stands empty still. All these years later, its shuttered windows looking out over the same beautiful bay. Talk to the elderly residents, the ones who were young adults or children then, and the thing you hear underneath the facts is not fear exactly. It is grief, and it is distrust. They lost something in those years that never fully came back, a way of life, a wholeness, a faith that when the authorities knock on the door and say leave, the leaving will be temporary, the leaving will be honored. The leaving will not simply erase your world. Many who left were rehoused far from the sea, far from the neighborhoods that had shaped them, in new towns that were safe and soulless. The old bonds frayed, and the lesson a great many of them took away, rightly or wrongly, was that an evacuation is not a rescue. An evacuation is a loss. And they have carried that lesson forward for 40 years, and they will hand it to anyone who comes to their door now with a chart and a warning. There is a folk phrase you hear in Pozzuoli for all of this, older than any observatory, and it is worth sitting with. The people here call the rising and falling of the ground the breathing of the volcano. La respirazione. As if the whole caldera were a great sleeping animal, and the ground going up and down were only the slow lift and settle of its enormous chest. It is a folk belief. It is not, technically, how magmatic fluid pressurization works. But like the myth of the buried giants, it is not a stupid belief. It is a belief that gets the essential thing exactly right, which is that this is a living process, patient and vast, and that the people who live on top of it have understood in their bones, for a very long time, what the instruments have only recently been able to measure. The ground breathes. It has breathed the columns of the market down under the sea and back up into the air. It breathed 40,000 people out of their homes in the 1980s, and it is breathing now, longer and harder than the record has ever seen, and the question that hangs over everything, the question the whole rest of this story exists to circle, is whether this breath is like all the breaths before it, or whether, this time, it is building towards something that does not exhale. To answer that, we have to leave the surface. We have to go down beneath the harbor and the espresso bars and the cracked door frames, beneath the Roman columns and the buried giants, into the thing that is doing all this. We have to look at what actually lives below Pozzuoli, how much of it there is, and how the scientists know. And then we have to open that paper from April, the one that traded a familiar kind of fear for an unfamiliar one, and find out what it actually says, and what a word like singularity means when it is not a metaphor, but a measurement. Because the number, the 163 centimeters, the height of a human being, the length of a forearm added in a single year, is not the story. It never was. The number is only the receipt. The story is what the receipt is for. Start with the year itself, because the year is where the strangeness lives. Take the ground at Pozzuoli and lay its whole modern history out flat, the way a geodesist does, as a single line climbing across a graph. For most of the last 2 decades that line rises, but it rises like a tired man climbing stairs, a step and a pause, a step and a pause. A few centimeters in a year here, a little more there, a brief settling, a shallow dip, as if the caldera had thought better of it. That is what unrest normally looks like. Patient, uneven. The breathing of the volcano, exactly as the old people said. And then you reach the most recent stretch of that line, and it stops behaving. Between January and the closing weeks of last year, in the span of a single calendar, the ground under Pozzuoli lifted roughly 25 centimeters. Say that number slowly. 25 centimeters. That is the length of a man's forearm, from the crook of the elbow to the tip of the middle finger. It is the distance from the floor to about the middle of your shin. It is nothing you would notice standing in the street. It is not a wave, not a wall, not a cliff. It is a hand's breadth and a half, added to the height of an entire city, in the time it takes the Earth to go once around the sun. That sounds like almost nothing. It is the single most alarming measurement in the modern record of this caldera, and to understand why, you have to stop thinking about the height and start thinking about the rate. There is a man who thinks about the rate for a living, and I sat with him while he worked. His name is Antonio Pepe. He is a geodesist with the Institute at the National Research Council that specializes in reading the ground from space, and his instrument is not a benchmark bolted into Roman stone. His instrument is orbiting 200 kilometers overhead. It is a satellite called Sentinel, part of a European fleet, and it carries a radar that fires a pulse of microwaves down at the Bay of Naples and listens for the echo over and over, pass after pass, every few days, forever. It does not care about the weather. It does not care about the dark. It sees through cloud. And by comparing the timing of the returning echo from one pass to the next, down to a fraction of the wavelength, it can tell you whether a patch of ground the size of a football pitch has moved toward the sky or away from it since the last time the satellite came around. Not by meters, by millimeters. The technique has a name that sounds like a spell and works like one: interferometry. The interference of 2 radar images, taken at different times, laid one over the other. And when Pepe pulls up one of these images on his screen, the deformation does not appear as a graph or a number. It appears as color, as rings. I watched him scroll through them, frame after frame of the same coastline, the harbor, the low hills, the crater of Solfatara, and painted across all of it a pattern of concentric bands, red bleeding into yellow, into green, into blue, and back to red, like the contour lines on a hiking map, or the growth rings of a tree, or the ripples spreading out from a stone dropped in still water. Each full cycle of color, each complete band from red around to red again, represents a fixed amount of ground movement toward the satellite. A fringe, they call it. One fringe is one increment of rising Earth, and the center of all those rings, the eye of that painted storm, sits almost exactly over Rione Terra, over the old condemned district on the highest ground in the city, the same spot where the benchmark reads 163 centimeters. The place the ground is lifting fastest is the place it has always lifted fastest. The animal breathes from the same lung it always has. Here is what Pepe wanted me to see, and here is why he scrolled slowly, one frame forward, then the next, watching my face instead of the screen. In the older frames, the rings are spaced wide apart, loose, generous. You could lay your thumb across the gap between one red band and the next. That wide spacing means the ground is rising gently across a broad area, a slow dome swelling under the town. In the newer frames, the rings crowd together. They tighten, the gaps close up. Where his thumb used to fit, now there is barely room for a fingernail. The bands stack against each other, red and yellow and green compressed into a dense knot over the harbor, and the tighter they pack, the faster the ground beneath them is climbing. Pepe did not say very much while he did this. He let the images do it. Frame, 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 and the rings drawing in on themselves, like the coils of a spring being wound tighter and tighter by a hand you cannot see. That is the image I cannot shake, and I think it is the honest one. A coiling spring. Not because a spring is dramatic, but because a spring is a system that stores energy. Every turn of the coil packs a little more force into the metal, and the metal shows you nothing, gives you no warning, sits there looking exactly like a spring until the moment it does not. The tightening fringes over Pozzuoli are the visible turns of that coil. And the thing that stopped me, sitting in that room, was not that the ground was rising. We knew the ground was rising. The town has known for 2,500 years. It was that the rising is speeding up. The rate of the rate is changing. Whatever is winding this spring is not winding it at a steady pace. It is winding it faster. And a rate that accelerates is a fundamentally different animal from a rate that is merely high. Let me be careful here, because this is exactly the kind of place where I could overstate it and lose you, and I am not going to do that. 25 centimeters in a year does not mean the ground is about to leap. It does not mean anything is going to happen next month or next year. It means the clock changed speed. That is what it means. For decades, the caldera breathed in a rhythm you could set a life to, and now, in the space of a few recent years, that rhythm has quickened in a way the modern instruments have never recorded here before. The number is unprecedented in the monitoring era, not the height, the pace. And a system that is accelerating is telling you something a system at a steady state never can, which is that it has more to give, and that it is finding it easier and easier to give it. Which raises the only question that actually matters, the one Pepe cannot answer from orbit, the one no radar echo can resolve. What is winding the spring? To answer that, you cannot stay on the surface. You cannot learn it from the fringes. You have to go down, into the rock, into the thing that is doing all of this. And to do that, I need to hand you off to a different kind of scientist, one who thinks not about millimeters at the surface, but about kilometers of crust beneath it. His name is Christopher Kilburn. He is a volcanologist at University College London, and he has spent a very long time thinking about Campi Phlegrae specifically, about this caldera and how its crust behaves when it is pushed. And the first thing Kilburn will do is take away the picture in your head. Because when I say the word volcano, you see a mountain, a cone, a single fiery throat with a plume above it. That picture is Vesuvius, across the bay, and it is useless here. Campi Phlegrae is the opposite of a mountain. It is a hole. It is a caldera, a vast collapsed basin roughly 13 kilometers across, formed in the deep past when enormous eruptions emptied the reservoir beneath and the roof of the emptied chamber fell in on itself. The burning fields are not a peak. They are the healed scar of a collapse. The town sits inside the wound. Now go down through that wound, through the crust, and picture the structure the way Kilburn does. Near the top, in the first kilometer or two, the rock is fractured and soaked. Groundwater, seawater, and gas percolate up through the cracks, heated from below, a whole plumbing system of superheated fluid moving through broken stone. This is the hydrothermal system, and you can meet it face to face at the Solfatara crater, where the ground hisses and the mud pots boil and the air reeks of rotten eggs from the sulfur riding up on the steam. That is the shallow layer. That is the part that breathes visibly. Keep going down. 3 kilometers. 4 kilometers. And there, somewhere in that depth range, sits the reason all of this is dangerous. A shallow magmatic system. Molten and semi-molten rock, not a single tidy lake of lava, but a complex, mushy region of partial melt and hot crystal and dissolved gas, waiting under the town. That is the engine. That is the deep source of the heat that drives the fluids, the pressure that lifts the ground, the whole slow inhale and exhale of the caldera. It is not at the surface. It is not, as far as anyone can tell, climbing toward the surface right now. But it is there. And it is the thing that makes the difference between an inconvenient rising of the harbor floor and a catastrophe with a name. And this is where Kilburn draws the line that the entire scientific fight is drawn along. Because the ground is rising. Everyone agrees the ground is rising. The debate, the real one, the one that keeps serious people awake, is about what, precisely, is pushing it up. There are 2 candidates. The first is the frightening one, the one that fits the mountain picture in your head. Fresh magma. New molten rock, rising from depth, intruding into the crust beneath the caldera, pushing the ground up the way a fist pushes up under a stretched sheet. If that is what is happening, then the material that erupts is already on its way, already moving, already committed, and the uplift is the direct signature of an advancing eruption. The second candidate is subtler, and for a long time it was the reassuring one. Not magma itself, but the fluids the magma heats. Water and gas, driven off the hot rock at depth, migrating upward, pressurizing the fractured crust, inflating the shallow hydrothermal system like air forced into the walls of a tire. In this picture, the ground rises not because molten rock is arriving under the town, but because pressurized steam and gas are swelling the rock that is already there. And crucially, in this picture, that pressure can rise, and stress the crust, and lift the ground, and shake it with earthquakes, and then, sometimes, bleed off again, without a single drop of new magma ever reaching the surface. This is the version in which the caldera can breathe hard and long, and still, in the end, only breathe. Here is the honesty this story demands. The distinction between those 2 mechanisms is not academic. It is the difference between an evacuation that saves 500,000 lives and an evacuation that empties a city for a crisis that quietly subsides. And it is genuinely, at this moment, unresolved. The gas coming out of Solfatara has a chemistry that people read for clues about how much of the deep magma is involved. The pattern of the earthquakes, the shape of the uplift dome, the speed of the seismic waves through the crust, all of it gets fed into the argument. And reasonable, expert, careful scientists look at that evidence and come down in different places. That fight is coming later in this story, and it deserves its own space, so I am going to leave it standing for now, unresolved, exactly as it stands in the literature. But Kilburn adds one thing here that neither camp disputes, and it is the thing that makes this caldera's situation worse than a simple sorting of magma from steam, and it is the thing almost nobody outside the field ever mentions. He is less interested, in a sense, in the source of the pressure than in the response of the crust to it. Because the crust is not a passive lid, it is a material, and materials fatigue. Think of a paperclip. Bend it once and it springs back. Bend it a second time, a little further, and it springs back a little less. Bend it enough times in the same place, and the metal there weakens, the crystalline structure damaged by all that flexing, until finally the bend that a fresh paperclip would have shrugged off is the bend that snaps it. The metal did not fail because the last bend was the hardest. It failed because of every bend before it. Now put the caldera in place of the paperclip. 1950, 1970. The great crisis of the early 1980s, when the ground rose almost 2 meters and 16,000 earthquakes rattled the town, and 40,000 people were pushed out of Rione Terra. And now this, the current unrest, running since 2005, longer and now faster than anything the instruments have logged. Each of those was a bend, and Kilburn's point, the one he has made carefully and repeatedly, is that they are not independent events. They compound. At each emergency, he has said, the crust is stretched just that bit further, so the later emergencies are building on the previous ones. The crust that is being flexed today is not fresh crust. It is crust that has already been bent, and bent again, and never fully recovered, weakened a little more with every episode, so that a stress that the caldera absorbed easily in the 1980s may be a stress it cannot absorb now. The rock is tired. It has been bending for a very long time, and a tired material breaks at loads that a rested one would carry. Hold that idea. The self-weakening crust, the paperclip that has been bent too many times, because it is going to come back, and when it does, it is going to be the difference between a frightening curve and a genuinely new kind of fear. Kilburn is at pains, always, to keep this honest in the other direction too, and I respect him for it. A stretched crust, even a fatigued one, even one being pushed toward the point where it fractures, does not guarantee an eruption. This is his line, and it is the crucial hedge. The rupture may open a crack through the crust, he says, but the magma still needs to be pushing up at the right location for an eruption to occur. In other words, the crust can break, the ground can fail, the caldera can pass a mechanical threshold, and still nothing molten need come out, unless the magma happens to be positioned and pressurized to exploit the crack. The breaking of the crust and the erupting of the volcano are two separate events, and one does not compel the other. That is real. That is the reassurance, and it is honest, and I am not going to take it away from you. But the breaking of the crust is not nothing either, and whether this crust is breaking, and how fast, and toward what, is exactly the question that a group of researchers set out to answer with mathematics. Which brings us to the paper. In April, a study appeared that did something the earlier work had not quite done. Its lead author is a researcher named Zaccagnino, and its analysis draws on the thinking of people like Kilburn about the mechanics of a failing crust, and what it argued was not that the ground was rising, which everyone knew, and not merely that the rising was accelerating, which the fringes over Pozzuoli already showed. What it argued was about the shape of the acceleration, and the shape, they said, was wrong. Or rather, it was not the shape everyone had assumed. For years, the working description of this unrest had been exponential, supra-exponential in some of the earlier Institute studies, parabolic in others. And those are already frightening words, because exponential growth is the growth of compound interest, of runaway processes, of things that get faster and faster without limit. But exponential growth, for all its menace, has a strange comfort buried inside it. An exponential curve never actually arrives anywhere. It climbs forever, doubling and doubling, approaching the vertical, but never reaching it, never hitting a wall, never naming a date. You can always tell yourself there is more runway. What Zaccagnino and colleagues argued is that the Campi-Phlegrae data does not fit that curve. It fits a different one, a worse one. They call it a regularized finite-time singularity. Sit with that phrase, because we are going to take it apart properly later, and it deserves care. But strip it to its bones, and here is what it says. A finite-time singularity is not a curve that climbs forever. It is a curve that arrives. It is a mathematical form in which some quantity does not merely grow, but grows in a way that races toward becoming infinite at a specific, finite moment in time. There is a point on the horizontal axis, a date, where the math says the value goes off the chart entirely. A vertical wall, not someday. Then. And when the researchers fit the observed uplift, and the observed seismicity to that form, and when independent analyses ran the same numbers, the curves converged. They pointed at a window. Not a single day, this is not prophecy, but a range, a span of a few years, into which the mathematics funnels. Between 2030 and 2034, I have read a great deal of frightening scientific literature for this work, and I will tell you plainly that watching a co-author trace that curve on a whiteboard, the gentle rise, the sharpening bend, and then the near vertical stroke of the marker climbing off the top of the board with a date written under it, is a different experience from reading a probability. Because a probability spreads the fear out. It says something might happen, somewhere in a fog. A finite time singularity does the opposite. It gathers the fear and points it. It says, if this model is right, and that is a real and enormous if, the system is not drifting toward trouble. It is converging on it. And the projection that accompanies the model is a number as concrete as the forearm on the graph. Cumulative uplift, they estimate, reaching in the neighborhood of 4 meters by the early 30s. 4 meters. Twice the rise of the great crisis of the 1980s, the crisis that condemned a district and emptied 40,000 homes and taught this town that an evacuation is a loss. Twice that, and arriving not as a random misfortune, but as the endpoint the equations point toward. And there is one line in the reasoning behind that model that I keep returning to, because it is the line that connects the mathematics on the whiteboard to Kilburn's tired paperclip, and it is the line that separates this from every ordinary alarm. The acceleration, they argue, is self-feeding. Remember the compounding crust, the rock weakened a little more by every episode of unrest. Now make it a loop. The crust is stretched, and stretching weakens it. And a weaker crust yields more easily to the next increment of pressure, which stretches it further, which weakens it further, which lets it yield again. Each turn of the coil makes the next turn easier. And the terrible implication buried in that loop, the sentence from the research that I cannot get out of my head, is that such a process does not need any new external trigger to sustain itself. It does not require fresh magma to surge. It does not require a switch to be thrown. Once a system enters that self-feeding regime, the winding of the spring becomes its own cause. The tightening of the fringes over Pozzuoli produces the conditions for the fringes to tighten further. The animal's breath is deepening the animal's need to breathe. Now, I owe you the counterweight, and I am going to give it its full strength, because this story lives or dies on refusing to lie in either direction. This is one paper. It is one model, appearing in one venue, and the scientific conversation around this caldera is not settled by it. Serious researchers at the Italian Institute that watches this ground every hour of every day have described the same trends in different mathematical language, as parabolic, as supra-exponential, and the choice of model is not a small thing, because the model is the thing that names the date. A parabola does not converge on 2030. A finite time singularity does. So, the argument over which curve the data truly fits is not an argument about decimal places. It is an argument about whether there is a wall out there in the near future, and if there is, when a city hits it. That argument is live, it is unresolved, and I am going to bring you the people on both sides of it at full strength later in this story, because they have earned that hearing. But even holding all of that skepticism, even granting every honest doubt about which equation is the true one, the frame of the conversation has changed, and it changed with that paper. For 20 years, the question at Campi Phlegrae was descriptive. How high? How fast? How does it compare to the 80s? Those are the questions of observation, and they are answerable with a benchmark and a satellite. The April paper replaced them with a question of a different kind entirely. A question that is no longer about what the ground has done, but about what the mathematics says it is committed to doing. It traded a familiar fear for an unfamiliar one. And I watched that trade happen in real faces, in the scientists who read it cold, who had spent careers being careful, watching them go quiet in the particular way that careful people go quiet when a piece of work forces them to take seriously a thing they had allowed themselves not to. Because a word like singularity, when it stops being a metaphor and becomes a measurement, changes what it is possible to say about a place where 500,000 people are going about their evening. And what that word actually means, mathematically, physically, and for the 500,000 people living inside the range of its projection, is the thing we have to understand next. So let us take the word apart, not to diffuse it, to understand it well enough that neither the doomer nor the debunker can lie to you about it. A singularity, in the plain language of physics, is a point where a quantity you are tracking runs to infinity in a finite amount of time. That is the whole of it. It is not a mystical thing. It is not a black hole opening over the Bay of Naples. It is a shape that a curve can take. Most curves in nature do not do this. Most curves rise and level off, the way a hot cup of coffee cools toward room temperature and then stops, the way a population grows until it runs out of food. Those are the polite curves. They approach a ceiling and they respect it. A singular curve does the opposite. It approaches a moment in time, a specific point on the calendar, and as it nears that point, it does not slow down. It steepens. The rate of change itself accelerates, and then the rate of the rate accelerates, and the whole thing rushes toward a vertical wall that the mathematics places at a definite date. That is what the April paper claims to have found in the uplift at Rione Terra. Not a curve that is climbing, a curve that is committed to a wall. And the wall, in their model, stands somewhere in the years between 2030 and 2034. Now here is where I have to be careful, because this is exactly the place where a channel like this one earns your trust or loses it forever. The mathematics saying a quantity goes to infinity at a date does not mean the ground at Pozzuoli is going to rise infinitely high on a Tuesday in 2031. Nothing physical goes to infinity. The earth does not permit it. Rock has limits. Long before any real quantity reaches the impossible number the equation promises, something physical intervenes. The rock breaks. The pressure finds an escape. The system reorganizes into something the old equation was never describing in the first place. So the singularity in the model is not a prediction of infinity. It is a prediction of a breakdown. It is the mathematics announcing, in the only language mathematics has, that the description it has been giving you is about to stop being true. I called a man who has spent his career living in exactly this uncomfortable territory, and I want to give you his framing carefully, because it is the most honest thing anyone said to me about this whole affair. Gordon Wu is a mathematician and a risk modeler, a man who prices catastrophe for a living, who builds the models that decide whether a coastline is insurable, whether a city is a bet a company can afford to take. He does not deal in drama. Drama is expensive and it is usually wrong. And his point about a finite time singularity is a distinction so sharp that once you hold it, the whole story sits differently in your hands. A singularity in a physical model, Wu will tell you, is a powerful framework. It is a way of saying that a system's own internal feedback has taken it over, that the process is now driving itself, that you are no longer watching a thing respond to outside pushes, but a thing generating its own acceleration from within. That is genuine information. It is not nothing. It tells you the animal is no longer merely breathing in response to the season. The animal's breathing has become the thing that governs the animal's breathing. But, and this is the whole of his warning, a singularity in a model is not a certainty of catastrophe. The model tells you the system is heading for a threshold. It does not tell you what is waiting on the far side of the threshold. That is the part the equation cannot reach. Sit with that, because it is doing two jobs at once, and both of them are true. It is a reassurance, and it is a deepening of the dread in a single breath, and anyone who gives you only one half of it is selling you something. The reassurance is real. A singularity is not a fuse. It is not a countdown to a specific horror. The date the model converges on is not the date of an eruption. It may not be the date of anything visible at all. It is the date at which the current behavior of the system becomes impossible to continue. The date at which this particular curve must end because the physics will no longer hold it. And that ending could take several very different shapes. Here is the first, and it is the gentlest. The uplift could reach a peak and stop. The pressure could find its own quiet equilibrium, the way it has done before in this caldera's long, patient history. The ground has risen and fallen here for 2,500 years, and most of those cycles ended not in fire, but in a slow subsidence, a settling, a return to sleep. The singularity in that reading is the peak of a bradyseismic crisis, the highest note the ground reaches before it exhales and comes back down. A crisis, yes, a frightening decade, certainly, but not a catastrophe. A regime change that the town survives, the way it survived the 80s. Here is the second shape, and it is stranger. The system could undergo what the researchers call a fundamental regime change without an eruption at all. The self-feeding process could resolve itself into some new state that the old model simply does not describe. A reorganization of the whole hydrothermal and mechanical system into a mode we have never observed in the monitoring era and therefore cannot yet name. That sounds abstract, and it is. But it is the honest scientist's answer, and I would rather give you the honest abstraction than a satisfying lie. The wall in the model might be the wall between the caldera we have been studying for 20 years and a caldera we do not yet have the vocabulary to study. And here is the third shape, and I am not going to soften it, because Wu did not soften it, and neither will I. Breaching the threshold could trigger an eruption. The self-feeding acceleration, if it is not resolved gently, if the crust does not find a quiet way to shed its stress, could culminate in the rock finally failing in the one direction that opens a path. Not because fresh magma has surged, remember. That is the part that unsettles the specialists most. The self-feeding process does not require new magma to arrive. It requires only that the system keep winding itself tighter until the weakest point in an already fatigued crust gives way. And if that weakest point happens to sit above the shallow magma that everyone agrees is down there at 3 or 4 kilometers, then the failure of the crust is not the end of the story. It is the beginning of a much older one. So which is it? Peak, or regime change, or eruption? And here is the sentence I promised you, the one that keeps the whole thing honest and keeps me awake. Nobody knows. The model does not say. The model cannot say. That is the precise nature of what a singularity does to prediction. It does not make prediction easier as the date approaches. It makes it qualitatively harder. Because the closer the system gets to the threshold, the more its behavior is governed by the exact details of how the rock fails. And rock failure at that scale is one of the least predictable processes in all of geophysics. The equation is confident about the approach to the wall and completely silent about what happens when the wall is struck. Think of it as the difference between two kinds of ignorance. 20 years ago, the ignorance at Campi Phlegrae was ordinary. We did not know how high the ground would rise, or how fast, but we knew what kind of thing it was. And we knew that as we got more data, we would understand it better. That is comfortable ignorance. It shrinks. The singularity replaces it with a harder kind. It says that as the system nears its threshold, the fog does not lift, it thickens. The place where you most need to see, clearly, is the place where the physics guarantees you cannot. That is the thing I could not get out of my head, and it is why I keep circling back to it. We have built the most sophisticated volcano monitoring apparatus on the planet over this caldera. Satellites read the ground to the millimeter. Sensors sample the breath of the Earth by the hour. and the mathematics is telling us that all of that vigilance is aimed at a system that is entering the one phase of its life in which vigilance yields the least. The instruments will see the ground rising. They already do. What they cannot see is which of the 3 doors it opens when it stops, which brings us off the page and into a room. Because for all the talk of curves and thresholds and the terrible silence of the equations, there is a physical place where this abstraction becomes a job that human beings do, in shifts, around the clock, with coffee going cold beside the monitors. And I went there. The Osservatorio Vesuviano sits in Naples, an institution older than the country it belongs to, watching this ground since the middle of the 19th century, since long before anyone had a word like Bradyseism to describe what it was watching. It is, by common consent among the people who do this work worldwide, the most closely watched volcanic system on Earth, and the beating heart of it now is a monitoring center where the data never stops arriving and the screens never go dark. Walk in, and the first thing you notice is how quiet it is. Not the quiet of nothing happening, the quiet of concentration. There are walls of monitors, and on them the caldera is rendered not as a landscape, but as a set of lines. Seismometers draw the ground's tremor as a running trace, the way a hospital draws a heartbeat, and when a swarm comes through, when a cluster of small quakes rolls under Solfatara in the small hours, the lines thicken and jump, and the room's attention sharpens without anyone raising their voice. Tilt meters measure the ground's lean, the way you would measure whether a table is level, except the table is a caldera 13 kilometers wide, and the measurement is fine enough to catch the ground tipping, by an amount you could not see if you stared at it for a lifetime. The GPS arrays, the same satellite geometry that lets a phone find a street, are tuned here to a precision that reads the swelling of the Earth in millimeters, station by station, all of them centered on the same rising dome beneath Rione Terra. And then there are the sensors that do not measure motion at all, but breath. At Solfatara, and at the vent called Pisciarelli beside it, the ground exhales. It has exhaled for as long as anyone has kept records, jets of steam and gas hissing from cracks in a bare, sulfur-stained plain. And the chemistry of that breath is one of the most important things the observatory watches. Because the ratio of the gases, how much carbon dioxide against how much water vapor, how much of the deep signature is present in the exhalation, is a message from below. It is the difference between a system heating from magmatic gas and a system merely stewing in its own hydrothermal juices. When the breath changes, the room notices. The geochemists sample those fumaroles and run the numbers, and the numbers feed into the same picture the seismographs and the tilt meters are building. A single portrait of a caldera assembled from a dozen kinds of watching at once. The man who oversees all of it is Mauro Di Vito, the observatory's director, and when he walks you through the alert system, he does it the way a person does who has explained it 1,000 times and knows that this time it matters. Italy runs a 4-tier scale, and the names are worth learning because they are the vocabulary in which a decision about 500,000 lives will eventually be spoken. Verde, green, background. The system doing what it does, no cause for concern. Giallo, yellow, attention. Something has changed, and the watching intensifies. Arancione, orange, pre-alert. The system is behaving in a way that could plausibly lead to an eruption, and the machinery of response begins, quietly, to turn. And rosso, red, alarm. The stage at which the plan is no longer a plan on a shelf, but an order given to a city. Campi Phlegrae is at Giallo, yellow. It was raised to that level in 2012, and it has stayed there ever since, through more than a decade of accelerating uplift, through the swarms and the swelling and the paper that named a date. Yellow, attention. And I have to be careful here, because the temptation is to hear that as complacency, and it is not. The alert level is not a measure of how frightened anyone is. It is a formal statement about the specific evidence for an approaching eruption, and the honest position of the observatory has been that the current unrest, dramatic as it is, has not yet crossed the threshold of evidence that orange would require. The gas chemistry, the depth of the seismicity, the absence of the particular signals that say magma is on the move toward the surface. On those specific grounds, the case for orange has not, in the institution's judgment, yet been made. And yet, the experts who watch this ground do not hide the other half of the sentence. Arancione is a realistic possibility. Given the pressurization that will not stop, given the crust that is being stretched, in the words of one of the people who study it, nearly to breaking point, the move from yellow to orange is not a distant hypothetical. It is a step the system could force at any time, and the room in Naples is built around the possibility that it will. That is what the vigil is. It is not waiting for something certain. It is standing ready for something plausible, hour after hour, year after year, while a curve that a paper says is heading for a wall climbs quietly across the monitors. I keep coming back to the human fact of it. There are people who do this job on the night shift. There is a person on duty at 3 in the morning when the fumaroles at Picciarelli shift their chemistry and a swarm rolls under the town, a person whose responsibility in that moment is to know the difference between the ground's ordinary restlessness and the beginning of the thing everyone has spent 20 years dreading. The instruments do not sleep, and the instruments have no opinion. The seismometer writes the swarm whether anyone is watching or not, but somebody has to read it. Somebody has to decide, in the small hours, whether what just happened is worth a phone call, and somebody further up the chain has to decide, if that call comes, whether it is worth waking a region. That is where the abstraction of the singularity comes to ground, not in an equation, in a tired person at a screen at 3 in the morning, holding the whole weight of a maybe. And here is the thing that turns the vigil from unsettling to something closer to vertigo. Suppose the machinery works perfectly. Suppose the geochemists catch the change in the breath, the seismologists catch the migration of the quakes, the tilt meters catch the ground beginning to move in the pattern that means the door is opening. Suppose every instrument does its job, and every human reads it right, and the observatory makes the call, and the alert goes to orange, and then, if the evidence demands it, to red. What happens then? What actually happens when the order is given? That is the question that takes you out of the quiet monitoring room and into a much louder problem, one that has nothing to do with physics and everything to do with roads. Because the plan exists. Italy has a national civil protection plan for Campi Phlegraei, a document that specifies, in the event of an eruption alarm, a mass evacuation of the red zone, the area designated as most at risk from pyroclastic flows, the avalanches of superheated gas and rock that are the caldera's deadliest weapon. The plan gives that evacuation 72 hours, 3 days to move the people out before the ground fails. And the number of people in that red zone is the number I have been carrying through this whole story, the one that recontextualizes every curve and every alert level and every tired reader at a screen. 500,000, 500,000 people, 3 days. And now look at the map. The red zone is not a scattering of villages with open country between them. It is a dense, continuous urban fabric on the western edge of one of the most crowded metropolitan areas in Europe, Pozzuoli, Baccoli, Monte di Procida, Quarto, and a substantial slice of Naples itself, the great city that spills right up against the caldera's rim. This is not a place where you can send people fanning out across the countryside in every direction, because in most directions there is no countryside, there is only more city, and beyond the city, the sea. The western Naples conurbation is a peninsula of humanity with the bay on one side and the caldera underneath, and when you need to empty it in a hurry, the geography does something cruel. It funnels. the exit routes converge. The 500,000 people in the red zone do not have 500,000 ways out. They have a handful of major roads, and those roads run through a handful of tunnels and over a handful of bridges. And here is the detail that stops you cold once you see it. That infrastructure is old. The tunnels and bridges that the evacuation plan depends on are themselves aging structures, and they sit in an active seismic zone, which is to say, they sit in the exact terrain that will be shaking during the very emergency that requires them to work. The plan asks the oldest, most vulnerable pieces of the transport network to bear the heaviest load they will ever carry, at the one moment the ground is most likely to be moving beneath them. The road out and the hazard are the same geography. I spoke about this with people whose job is to make the plan real, and the most sobering voice was Luigi D'Angelo, a senior figure in Italy's Department of Civil Protection, a man who has spent years on the unglamorous, essential work of turning a document into an operation. And his message is not panic. It is something more useful and more troubling than panic. It is a clear-eyed insistence on the distance between the plan on paper and the reality on the ground. They test it. There is an exercise called Phlegraean, a large-scale drill that puts the whole apparatus through its paces: the Department of Civil Protection, the Campania region, the individual municipalities, all of them coordinating the way they would have to coordinate on the worst day. Tabletop exercises, scenario runs, rehearsals of the choreography by which a region moves 500,000 people to safety. And the exercises are valuable precisely because they surface the problems that a document cannot. They reveal, again and again, the persistent gap. The gap between the scientific model and the operational readiness. The gap between knowing, in the abstract, that 500,000 people must move, and actually moving them through a narrow, seismically active urban corridor whose exits are aging tunnels and bridges. D'Angelo's framing of the whole enterprise is the one I keep returning to. The challenge, he has said, is bridging the gap between scientific modeling and operational readiness, between the equation and the road, between what the monitors in Naples can tell you and what the tunnels under the city can actually deliver. And he is at pains, as the honest people in this story always are, to say that no eruption is currently imminent, that the caldera's breathing has not become an emergency, that the plan is a precaution and not a countdown. But he does not pretend the precaution is easy, or solved, or safe. He calls it what it is: a high-stakes test of emergency logistics, a test that has not yet been taken for real, over a city that does not get to choose the day. And that is the thing that sits underneath the whole apparatus of vigilance, the thing the quiet monitoring room and the aging tunnels have in common. All of it, the satellites and the seismometers, and the gas sensors, and the 4-tier scale, and the 72-hour plan, all of it exists to buy time, to catch the change early enough that the order can be given while there are still 3 days left to give it. The entire system is a machine for turning a signal into a warning, into an evacuation, fast enough to matter. And the singularity, the self-feeding curve heading for its wall, is the one process in nature designed to make that machine's job hardest at the exact moment it matters most, because the plan assumes a signal you can read in time. And the mathematics is warning that the closer the system comes to its threshold, the less legible that signal may be. So we have the machine, the satellites, the seismometers, the 4 colors on the scale, the 72 hours, the tunnels, a whole apparatus built to buy time. And now I want to leave that apparatus behind for a while, because there is a question it cannot answer, and it is the only question that finally matters. Who does it buy the time for? 500,000 people. That is the number that has hung over this entire story, the red zone population, the figure printed in every plan and every headline. But 500,000 is not a number. It is an abstraction that keeps you at a safe distance from the thing itself, the way a satellite radar image keeps you a safe distance from a crack in a wall. So, let me bring it closer. Let me take you down into the streets of Pozzuoli and Rione Terra and the district of Bagnoli, and let you meet a few of the people who are not, tonight, planning to leave. Because here is what the coverage almost always gets wrong. It frames the people who stay as the problem, the stubborn ones, the deniers, the irrational holdouts who will have to be dragged from their homes on the worst day, complicating the logistics, endangering the responders, refusing the science that is trying to save them. And that framing is not just unkind, it is wrong. It misreads the situation so completely that it misses the actual difficulty, which is not stupidity. It is that the people who stay may be making a decision that is, on their own terms, entirely rational. There is a man in Pozzuoli, retired now, who spent his working life on the docks. His family has lived in the same building for 4 generations. Read that again, slowly. 4 generations. His great-grandparents lived under that roof, and his grandparents, and his parents, and him, and the walls of that apartment have absorbed 100 years of one family's ordinary life. The christenings and the funerals, the arguments and the reconciliations, the smell of the same kitchen on a Sunday afternoon passed down like a language. When you tell a man like that to leave, you are not asking him to relocate. You are asking him to sever a rope that his family has been braiding for a century, and you are asking him to do it on the strength of a probability, a model, a curve on a screen in a building in Naples that says something might happen sometime in a window that opens a few years from now. He knows the ground moves. Of course he knows. He has felt it his whole life. He has watched the harbor go shallow and the doorframes go crooked. He does not deny the Bradycism. He simply weighs it differently than the model does. He weighs the certain loss of everything he is against the uncertain arrival of a catastrophe that the scientists themselves are careful to say is not imminent, may not come, may resolve without an eruption at all. And on that scale, the certain loss is heavier. The rope wins. There is a young mother in the same town who says something simpler and even harder to answer. She cannot afford to move. That is the whole of it. The apartment she lives in is not an investment she can liquidate and reinvest somewhere safer. It is the only roof she can pay for. Moving is not a decision she gets to make by reading a Nature Communications paper and rationally updating her risk assessment. Moving requires money she does not have, to a place that does not exist for her, away from the network of family and neighbors, and cheap childcare, and the corner shop that lets her run a tab at the end of the month, the invisible economic lattice that makes a poor family's life just barely possible. Take her out of that lattice and drop her, alone, in some safer town where she knows no one and can afford nothing, and you have not saved her. You have wrecked her. She is not weighing a small probability of death against nothing. She is weighing it against the near certainty of ruin. And she has decided, the way a great many people quietly decide, that the ruin she can see is worse than the disaster she cannot. And there is a bar owner, a woman, who lived through 1984, who was there when the ground rose almost 2 meters, when the harbor went too shallow for the boats, when 16,000 earthquakes rattled the plates on her shelves and 40,000 of her neighbors were moved out, and Rione Terra was condemned and emptied and left to stand there, hollow, a whole medieval town turned into a monument to the last time the experts said, go. She left that time, and she came back, and she rebuilt. With her own hands and her own money, she rebuilt the thing they had told her to abandon, and it did not erupt, and the years went by, and the walls she had rebuilt held, and she poured coffee behind the same bar for 4 decades. Now, they are telling her again. And she is looking at the empty windows of Rione Terra just up the hill, the town that was evacuated and never repopulated, and she is drawing the lesson that anyone with her history would draw. Last time they were wrong. Last time leaving cost everything, and staying would have cost nothing. Why should this time be different? That is not denial. That is memory. The 1980s crisis did not culminate in an eruption. It rose, and it terrified everyone, and it displaced a town, and then it subsided, and the ground came back down, and the disaster that justified the exodus never arrived. For the people who lived it, that is not a reassuring precedent. It is a scar. It taught a generation that the ground's fury can be real, and the evacuation can be real, and the eruption can still, in the end, simply not happen. And it left behind a distrust of official orders that no amount of new data seems able to dissolve, because the distrust is not about data. It is about being burned, about having done the responsible thing once, at enormous cost, and having been made to look, in hindsight, like a fool. There is a phrase you hear in these streets from a local business owner named Giuseppe Minieri, and it captures the whole psychology in 5 words. We have Bradyseism in our blood. Say it aloud and feel what it does. It takes the thing the scientists describe as a hazard and reframes it as heritage. Not a threat that arrived, but a condition that has always been. The ground here has been rising and falling for 2,500 years, since before the Greeks named the place, since before Rome made it a port. The shellfish borer holes 7 meters up the marble columns of the Serapeo are proof that this ground breathes on a timescale that dwarfs any single human life. To the people who live on top of it, that is not an argument for leaving. It is an argument for belonging. The ground has always moved. Their families have always stayed. The two facts have coexisted for 100 generations, and the residents of Rione Terra and Bagnoli are, in their refusal, simply asserting the oldest fact about their home, that it is theirs, and that people have always lived here anyway. I lean a certain way on this, and I will tell you which way. I think the model is probably telling us something real. I think the acceleration is not noise. And I still cannot bring myself to call these people irrational, because rationality is not one thing. There is the rationality of the equation, which sees a curve heading for a wall and says, move. And there is the rationality of the rope, which sees a century of belonging and a scar from the last false alarm and says, stay. Both are doing arithmetic. They are just weighing different quantities, and neither of them is stupid. And the tragedy of this place is that both of them might be right up until the exact moment one of them is catastrophically wrong. Hold those faces. The dock worker, the mother, the woman behind the bar. We are going to come back to them, because in the end, this whole story is about them and no one else. But now I want to take you somewhere they cannot go. I want to take you down toward the thing itself. There is a place in the caldera where the invisible system becomes, for a moment, almost visible. Where the abstraction of pressurized hydrothermal fluids stops being a phrase in a paper and becomes something you can smell and feel on your skin and hear bubbling under your feet. It is called the Solfatara. Picture a shallow crater, an oval bowl of pale ground, scooped out of the landscape, its floor cracked and crusted, and stained in yellows and oranges and bone whites, the colors of a chemistry set left open in the sun. This is one of the many vents that pock the burning fields, but it is the most eloquent. The Romans thought it was an entrance to the underworld, and standing in it, you understand why. The ground is warm through your shoes. The air is thick with the smell of rotten eggs, hydrogen sulfide, sharp enough to sit at the back of your throat. Jets of steam hiss out of fissures in the rock, and in one corner there is a pool of gray mud, the Fangaya, that does not sit still. It seethes. It burps and swells and collapses, gas pushing up from below in slow, fat, deliberate bubbles, as if something enormous were breathing directly beneath the surface of the Earth. Which is exactly what is happening. The fumaroles here run hot. The hottest reach around 160 degrees Celsius at the vent, well past the boiling point of water, hot enough that the steam comes out with force. And the reason to care about all of this, the reason a crater full of stinking mud is one of the most important scientific instruments in the whole caldera, is that the gas coming out of the ground is a message. It is a chemical telegram from 4 kilometers down, and if you know how to read it, it tells you things the satellites cannot. The man who reads it is a volcanochemist named Giovanni Chiodini of the INGV, and he has been reading this particular telegram for 2 decades. Chiodini's work is patient in a way that is almost invisible from the outside. He measures the flux of gas from the fumaroles, how much carbon dioxide is coming out of the ground, how much hydrogen sulfide, what the ratios between the different gases are, and how those ratios change from year to year. It is unglamorous, meticulous, and it is one of the clearest windows we have into what the caldera is actually doing beneath the noise. And what it has shown over these years is not reassuring. The gas output has climbed, not gently. The flux of carbon dioxide from the Solfatara system has risen sharply, and since around 2020, the increase has been pronounced enough to demand attention. More gas, coming out faster. But the raw quantity is not even the important part. The important part is what the chemistry of that gas reveals about where it is coming from. Because there are, broadly, 2 sources for the gas you smell in that crater. One is the shallow hydrothermal system itself, the water and the rock stewing away a kilometer or so down, cooking off its own vapors. The other is deeper. It is magmatic. It is gas that has separated from the magma body several kilometers below and risen up through the crust to join the hydrothermal brew. And Chiodini's measurements, over time, have tracked a shift in the balance between those 2 sources. The magmatic contribution has been growing. More of the gas coming out of the Solfatara is arriving from deep, from the magma, than used to be the case. Chiodini puts it with a scientist's restraint. The increasing magmatic contribution in the gases, he has said, suggests an important evolution in the dynamics of the Phlegraean volcanic system. Read that carefully, because the restraint is hiding something significant. An important evolution. The system is not just doing more of what it was doing. It is changing what it is doing. The relationship between the deep magma and the shallow crust is shifting, and the direction of the shift is toward more magmatic gas, more heat rising from below. And here is where the chemistry connects to everything else in this story. This is the mechanism made visible. Remember the debate from earlier, the 2 candidate causes for the uplift. Fresh magma physically pushing up versus pressurized fluids inflating the crust. Chiodini's gas measurements suggest these are not really rival explanations at all. They are 2 ends of the same process. The rising magmatic gas is heating the hydrothermal system. The heated fluids expand and pressurize. The pressurized fluids inflate and weaken the shallow crust. The gas is the messenger and the mechanism at once. It carries heat up from the magma, and that heat is what drives the deformation that the satellites measure as centimeters of uplift at Rione Terra. The rising gas is also telling us something about the rock itself. Gas has to travel to reach the surface. It moves through fractures and pores, through the permeability of the crust. And when the flux rises sharply, it can mean the pathways are opening up, that the rock is becoming more permeable, more fractured, more able to let the deep gas through. Which brings us right back to Christopher Kilburn's bent paperclip, the crust fatiguing under repeated stress. A more permeable, more fractured crust is a more fatigued crust. The gas rising through the Solfatara is, in a sense, breathing through the cracks that the accumulated strain has been slowly opening. The chemistry and the mechanics are describing the same weakening from 2 different directions. I should be honest about one thing, because it matters. You cannot today walk down into the Solfatara crater the way visitors once could. It was for centuries a destination, a place tourists came to marvel at the steaming ground and cover themselves in the therapeutic mud. But it has been closed to the public since September 2017, after a fatal accident in which people died on that unstable, superheated ground. It remains under legal restriction. The scientists who monitor it do so under controlled conditions, not on a casual stroll. And there is something bleak and fitting in that closure. The most vivid, visceral window into the caldera's hidden system is now a place you are not allowed to stand, sealed off precisely because the ground there is too dangerous to trust with a human body. The Earth put up a warning of its own, and we obeyed that one. So, the gas is rising. The magmatic signature is growing. The crust is fracturing and letting more of the deep breath through. The chemistry agrees with the geodesy, agrees with the seismology. Every instrument in the caldera, measuring different things by different methods, is pointing in the same uncomfortable direction. And that convergence is exactly what makes the next question so unbearable to sit with. Because if all the signals agree that the system is evolving towards something, then everything comes down to what happens when the moment arrives. And on that, history offers not one answer, but two, and they could not be further apart. Let me tell you about two other calderas in two other countries that stopped being case studies and started erupting, because they are the only honest way to understand what is actually at stake in the tunnels and the plan and the 72 hours. They are the before and after, the winnable version and the losable version, standing side by side. The first is Rabaul in Papua New Guinea. Rabaul was a town built inside a caldera on a beautiful harbor ringed by volcanic vents, and in September 1994, the caldera erupted. Two vents went at once on opposite sides of the harbor, Vulcan and Tavervur, and they buried the town in ash. Roofs collapsed under the weight of it. Buildings caved in. When it was over, something like 80% of the structures in Rabaul were gone. The town, as a town, effectively ceased to exist. And here is the thing about Rabaul that should keep the planners in Naples awake. There were warnings. There were seismic signals. The volcano did not strike out of a clear sky, but the formal, organized evacuation of the city center did not happen in time. What saved lives, and many lives were saved, was informal. It was the memory of the elders, who had lived through the previous eruption decades before and recognized the signs. It was people watching the animals behave strangely and deciding, on their own authority, to get out. The community's own memory did the work that the official machinery failed to do fast enough. People survived Rabaul largely in spite of the formal system, not because of it. And the town was lost anyway. Now, the other. Mount Usu in Japan in the year 2000. Usu is a volcano with a long, well-documented history of eruption, and it sits near towns, near tens of thousands of people. In March 2000, it erupted, and the number of people it killed was 0, not a low number. 0. The reason has a name. There was a volcanologist named Hiromu Okada who had studied Usu for so long, so closely, that he was known as the family doctor of the mountain. He knew its moods the way a physician knows a lifelong patient. And when the premonitory earthquake swarms began, he and his colleagues read them correctly and early. They understood what the mountain was about to do. And crucially, the warning was believed, and it was acted upon, and more than 15,000 residents were evacuated in an organized way 2 full days before the eruption. 2 days. When the volcano finally blew, the danger zone was empty. The houses were destroyed. The people were not. 2 calderas, 2 eruptions. One erased a town and depended on folk memory to save its people. The other lost its buildings and saved every single life. What made the difference? The volcanologist Rebecca Carey has thought hard about exactly this divergence, and her analysis strips it down to a small number of variables that have almost nothing to do with the volcano and almost everything to do with us. The first is institutional trust. Whether the authorities can act on the scientific data before the crisis peaks, and whether the population believes them enough to move when told. The second is infrastructure and planning. Whether the hazard maps exist, whether the routes are established, whether the choreography has been worked out in advance instead of improvised in the panic. And the third is political will. The raw courage to order the displacement of tens of thousands of people at enormous cost and enormous risk of being wrong before the eruption is certain. Because it is never certain until it is happening, and by the time it is certain, it is too late. Sit with that list against everything we have already seen in the Bay of Naples. Institutional trust in a community scarred by 1984, where the woman behind the bar remembers being told to leave for a disaster that never came. Infrastructure in a corridor of aging tunnels and bridges in an active seismic zone. Political will to move not 15,000 people, but 500,000 through that corridor in 72 hours. Usu had a family doctor who was trusted, a manageable population, and the will to pull the trigger early. Rabaul had warnings that the formal system could not convert into action in time. Campi Phlegrae has the best monitoring apparatus of any caldera on Earth. It has the satellites and the gas sensors, and the seismometers, and a chemist reading the breath of the solfatara, and a paper in Nature Communications drawing a mathematical wall across the early 2030s. It has, in some ways, more knowledge than Usu ever did. And it has, in every other way, a harder problem than Rabaul ever faced. More people, a denser city, a narrower way out, a longer memory of being told to run for nothing. Which is why the two precedents matter so much. They prove that the outcome is not written in the rock. Usu and Rabaul sat on the same physics. The difference between them was not geological. It was human. It was trust and planning and the courage to act on incomplete information, which means the Italian case is genuinely, terrifyingly, both winnable and losable. The eruption, if it comes, will not decide how many funerals there are. The decisions made before it will. The decisions that, as we are about to see, have not yet been made. So let us go back to the water, and to the instruments, and to the people who are watching them right now, in the late spring of the year we are living through, to see whether the story has moved while we were away in Japan and Papua New Guinea. It has. The first thing to understand about the monitoring room at the Osservatorio Vesuviano is that it does not feel like the movies. There is no red light spinning on the ceiling. There is no siren. There is a bank of screens, and there is coffee, and there is the specific quiet of people who have been doing the same demanding thing for a very long time and have learned not to let the pace of the work show on their faces. On this particular morning, the team is assembling the weekly report. It is a routine document. It goes out on a schedule. It has gone out in one form or another for years, and the routine of it is the point, because the routine is what keeps a room like this steady when the numbers inside the document are anything but. The person at the near terminal is pulling the latest geodetic data. The satellite passes come in on their own timetable, indifferent to the working week, and the ground stations feed their positions in continuously, second by second, a stream of coordinates that describes exactly where the surface of Pozzuoli is at any given moment relative to where it used to be. And the number that comes up on the screen is the number we already know in our bones by now. The uplift at Rione Terra, the benchmark on the highest ground, the point of maximum deformation, stands at roughly 163.5 centimeters since this phase of unrest began back in 2005. Of that total, around 25.5 centimeters has arrived since January of last year. In a single stretch of months, a quarter of a meter. And here is the part that changes the temperature in the room. The rate has not slowed. Everyone in that space has spent years half hoping for the graph to bend the other way. That is the outcome that the older residents remember, the outcome from the crisis of the 1980s, when the ground rose almost 2 meters, and then, over years, sagged back down, and the town got its uneasy peace. Every Bradyseismic crisis before this one has done that. It rises, and it peaks, and it stops, and it settles. A monitoring scientist who has watched this caldera for a decade is, underneath the professionalism, waiting for the peak, waiting for the plateau, waiting for the line to lie down. The line has not lain down. As of late March, the data confirms what the spring passes were already whispering. The acceleration continues, not a plateau, not a bend toward rest, a curve that is still steepening. And overlaid on the smooth curve of the uplift is the other data stream, the one that comes not from satellites, but from the seismometers buried around the caldera. And this is where the mood in the room tightens from concentration into something closer to vigilance. Across March and April of this year, the instruments logged swarms of micro-earthquakes, not large ones, not the kind that knock pictures off walls, small tremors, clustered in time, arriving in bursts, dozens in an afternoon. On their own, unremarkable. This is a restless caldera, and it has been shaking for years. The person mapping the swarms is not worried about the size of these earthquakes. They are worried about the depth. Watch what they do on the screen. They plot each earthquake as a point in 3 dimensions, latitude and longitude, and, crucially, depth below the surface. And when they animate the swarms of these recent months in sequence, a pattern emerges that no one wants to see, but everyone in that room knows how to read. The hypocenters, the points underground where the rock is actually breaking, are getting shallower. The fracturing that used to cluster deeper in the crust is now concentrating within the first 2 to 4 kilometers below the town. Higher, closer, nearer to the surface, nearer to the streets, nearer to the schools and the harbor and the marble columns of the Serapeo, with their band of ancient shellfish holes 7 meters up. Shallowing hypocenters, 2 words that mean the fatigue is climbing. Think back to Christopher Kilburn and the paperclip. The crust bends, and each bend weakens the metal a little more, until the metal that has been bent one too many times snaps, not because the last bend was hard, but because it was the last one the metal could take. When the fracturing migrates upward like this, it is a sign that the layer of rock being worked is thinning, that the pressure driving all of this, whether it is fresh magma at 3 or 4 kilometers, or the pressurized hydrothermal fluids that Giovanni Chiodini has been tasting in the breath of the Solfatara, is finding its expression closer and closer to the roof of the system. And the roof of the system is the ground people stand on. Now hold that live data stream up against the paper. The April study, Zaccagnino and his colleagues, the regularized finite time singularity, the mathematical wall across the early 2030s. When that paper landed, it was a model, a curve fit, a projection made from data that already existed, arguing that the acceleration was not the gentle exponential everyone had assumed, but something self-feeding, something converging on a finite point in time somewhere between 2030 and 2034. A model can be wrong. A model is only as good as the next month of data, and the next, and the next. And here is the thing that makes the monitoring room so quiet this spring. The next months of data have arrived, and they agree. The live measurements, the uplift that has not slowed, the swarms that keep coming, the hypocenters climbing toward the surface, all of it is tracking the accelerating trend that the model predicted. The paper said the system was self-driving and getting faster. The instruments, month after month, keep saying the same thing back. There is no comfortable divergence to point to. No reassuring gap where reality has stepped off the model's grim path. The forecast and the observation are shaking hands. This does not mean an eruption. It cannot be said often enough, and the scientists themselves say it more insistently than anyone. There is no evidence of an imminent eruption. What the convergence means is that the underlying volcanic process is undergoing a fundamental change, and that the shape of that change is exactly the shape the mathematics warned about. And there is a nearer worry than the eruption, one that gets less attention because it is less cinematic, and it deserves a moment of its own. Listen to how a seismologist frames the short-term risk. Greg Barroza at Stanford has put it plainly. One of the biggest concerns, he has said, is not an eruption. It is a moderate earthquake at shallow depth. Sit with the geometry of that. The rock is breaking higher and higher in the crust, right beneath a dense city of old buildings, some of them centuries old, in a corridor of aging tunnels and bridges. You do not need a volcano to open up to do enormous damage there. You need a single shallow earthquake of moderate size, in the wrong place, at the wrong moment. And the thing that hurts people is not lava. It is masonry. The shallowing hypocenters are not just a warning about the volcano. They are a warning in their own right, today, this spring, about the ground beneath the streets. So, the machine is working. That is the honest summary of the monitoring. Every instrument we have met across this story, the Sentinel satellites reading the tightening fringes, the seismometers logging the shallow swarms, the gas sensors at the Solfatara measuring a carbon dioxide flux that has climbed sharply since around 2020, the whole converging apparatus is doing precisely what it was built to do. It is watching, it is measuring, it is telling the truth about the ground, which leaves the one question the machine cannot answer. The machine can tell you what the ground is doing. It cannot tell you what to do about it. And that is where the story stops being about physics and becomes about the hardest decision in the whole affair, a decision that, as of this spring, has still not been made. Here is the shape of the problem, and I am going to lay it out as cleanly as I can, because it is the moral center of everything we have been circling for hours. Italy's civil protection system is one of the most sophisticated disaster management structures in the world. It has hazard maps. It has an evacuation plan. It has the 4-color alert scale, verde, giallo, arancione, rosso, that we sat inside earlier. It has a target window, 72 hours, to move 500,000 people out of the red zone. It has, on paper, thought about all of this more carefully than almost any other community living on top of a caldera anywhere on Earth. And yet, despite all of that, despite the accelerating data, despite the paper, despite the shallowing swarms, there is one thing the system does not have. It does not have a published, binding, quantitative trigger. There is no number. There is no line in a document that says, when the uplift rate reaches this value, or when the seismicity crosses this threshold, the mandatory evacuation of 500,000 people begins, automatically, without further debate. No such threshold has been publicly codified. Now, before that sounds like negligence, understand why it is so agonizingly hard, because it is not negligence. It is a genuine, possibly unsolvable dilemma. Set a threshold too low, too cautious, and you will almost certainly trigger a false alarm. You will move 500,000 people at colossal cost through the narrow corridor into temporary accommodation, away from their homes and jobs and livelihoods, for a crisis that, like the crisis of 1984, then peaks and subsides and does nothing. And when that happens, you do not just waste money. You destroy something far more precious and far harder to rebuild. You destroy trust. Remember the woman behind the bar in Pozzuoli, who lived through '84, who was told to run for a disaster that never arrived, and who will hesitate the next time she is told to run. Every false alarm mints 10,000 more people like her. And in a place where the outcome depends, as Rebecca Carey showed us, on whether the population believes the authorities enough to move when told, a false alarm is not a harmless precaution. It is a wound to the exact faculty you will need most on the day it is real. But set the threshold too high, wait for more certainty, wait until the signs are unambiguous, and you run straight into the other wall, because the eruption, if it comes, is never certain until it is happening. That was the lesson of the precedents. By the time the danger is beyond argument, the 72-hour window has already closed. A missed alarm, an evacuation ordered too late, does not wound trust. It kills people. It fills the rooms. It turns a number on a screen into funerals. That is the recursive problem. False alarm destroys trust, which you need to evacuate. Delayed alarm destroys lives, which is the whole point of evacuating. And the space between those two failures is where someone, some actual human being, with a name and a job and a phone that will ring at the worst possible hour, has to stand and decide. Fabrizio Curcio has stood in something close to that space. As a former head of Italy's Civil Protection Department, he has spent his career in exactly this territory, the territory between what the scientists can say and what the public can bear, between the model and the mob, between the cost of moving and the cost of not moving. And the position of a figure in that role is not to pretend the uncertainty away. It is to manage the tension between scientific uncertainty and public safety without ever being granted the luxury of certainty on either side. The scientists hand up a probability, a range, a converging window of years, not a date. And from that, someone has to fashion a yes or a no, a go or a stay, that will govern the lives of 500,000 people. There is no equation that turns a probability into that decision. There is only judgment and courage and the knowledge that history will grade you against an outcome you could not know when you chose. And this is where I want to bring in a voice from a different discipline entirely, because it reframes the whole thing. Sabina Leonelli is not a volcanologist. She is a philosopher of science, an expert in how data is governed and how knowledge is made and trusted. And what a thinker like Leonelli sees in Campi Phlegrae is not primarily a geological problem. It is a problem about the relationship between what we can measure and what we are willing to act on. The dilemma is recursive, she would point out, because trust and action feed each other in a loop. You need trust to act, and premature action erodes trust, and eroded trust makes the next necessary action harder, and around it goes. The question is not simply what the sensors read. The question is, who gets to decide what a reading means, and whether the people whose lives depend on that decision have any reason to believe the decider. This is the honest broker's version of the whole story, and I am going to say it as plainly as I know how. The gap that matters most in the Bay of Naples right now is not a gap in the science. The science is astonishingly good. The satellites are watching. The gas is being read. The paper has been written and peer-reviewed and published in one of the most respected journals in the field. The gap is between what the science can say and what the governance has not yet decided. The instruments have done their part. The mathematics has done its part. And now the ball sits in the one court where instruments and mathematics cannot follow, the court of political will, of institutional courage, of a decision that has to be made by people, for people, on incomplete information, before the moment when the information finally becomes complete, and it is already too late. Recall the three variables one final time: institutional trust, infrastructure and planning, political will. The Italian case is strong, extraordinarily strong, on the science that underpins all three, and it is unresolved, genuinely and dangerously unresolved, on the human machinery that has to convert that science into a choice. No published trigger, no codified line, a plan to move 500,000 people, and no agreed answer to the only question that plan really turns on, which is when. That is the climax of this story, and I am not going to dress it up as anything more comfortable than it is. There is a caldera under a city. The ground is rising, and the rate is not slowing, and the rock is breaking closer and closer to the surface. And a credible paper says the system is converging on a threshold in the early 2030s, and the live data keeps agreeing with the paper, and 500,000 people live on top of it, and no one has yet decided, in any binding way, what number makes them move. So, let me take you back, one last time, to the water. It is evening in Pozzuoli. The light is going down over the Bay of Naples, the way it has gone down for 2,500 years. Over the same curve of shoreline the Greeks chose and the Romans built their port on. And across the bay, the silhouette of Vesuvius is turning from gray to violet to black. The waterfront is coming to life. The restaurants along the harbor are setting out their tables. There is the clatter of plates, the scrape of chairs on stone, the smell of frying and lemon and salt. Families are arriving for dinner. Somewhere a scooter buzzes past. The bar owner who lived through '84 is pulling the first coffees of the evening. The retired dock worker, 4 generations of his family in one building, is taking the evening air. The young mother who cannot afford to relocate is carrying a child down toward the seafront. Giuseppe Minieri, who told us the Bradyseism is in their blood, is somewhere in this ordinary, luminous, completely alive scene. And beneath all of it, invisibly, silently, the ground is rising. Not felt, not seen. There is nothing to watch. The uplift is measured in millimeters over weeks, far too slow for any human sense to register. You could stand on the harbor wall your whole life and never feel the surface lifting beneath your feet. But it is lifting. Down in the harbor, a GPS logger, one of the ground stations feeding the stream we watched the monitoring team read this morning, is doing what it does every second of every day. As the plates are set on the tables and the coffee is poured and the child is carried toward the water, the logger records another fraction of a millimeter of upward motion, and another, and another. The town eats dinner, the ground keeps climbing. That is what it means to live inside a singularity. Not the mystical thing, the mathematical thing, a curve that is still steepening, under a life that refuses to stop being a life. I asked, in a manner of speaking, everyone in this story to say one thing about what they are choosing to believe or to do before 2030 arrives. And their answers, taken together, are the closest thing this account has to a resolution, which is to say, they are not a resolution at all. They are a way of living without one. The scientist chooses to keep measuring, to keep the instruments honest, to publish what the data says even when the data is frightening, to insist on the sentence that matters most, that identifying when the system is likely to reach a breaking point is not the same as knowing what will happen at that breaking point. Davide Zaccagnino himself has been careful to say it. The paper identifies when the system is likely to reach a breaking point. It cannot determine what will happen at that breaking point with the current data. Peak and stop, regime change without eruption, or the crust failing above shallow magma. The wall is on the map. What lies on the far side of the wall is not. The official chooses to hold the tension without resolving it prematurely. To keep the alert at Giallo, to keep the 72-hour plan ready, to keep buying time with early warning, and to carry, quietly, the knowledge that the hardest decision has not been delegated to any number and cannot be, that it will come down, in the end, to a person in a room. And the resident, the dock worker, and the mother, and the bar owner, and Giuseppe, chooses to stay. To eat dinner on the harbor, to open the bar in the morning, to raise the child within sight of the water, to live, deliberately and with open eyes, on ground that is silently accelerating, because it is home, because it has been home for centuries, because the Bradyseism is in the blood, and because the alternative, to abandon the place for a catastrophe that may still, as in '84, never come, is its own kind of loss. None of these are the wrong answer. That is the thing this story finally teaches, if it teaches anything. The scientist measuring, the official waiting, the resident staying, each is a rational response to a situation that offers no rational certainty. They are all, in their way, refusing false comfort while insisting on human agency inside a story that has not ended and will not end for years. We began with the ground remembering. The shellfish holes 7 meters up the marble columns, the town that sank and rose, the slow breath of the earth over 2.5 millennia. And we end with the ground rising still, a fraction of a millimeter at a time, under a dinner table on the harbor at Pozzuoli, on an evening that looks exactly like every other evening and is not. The precedents proved the outcome is not written in the rock. Usu saved every life. Rabaul lost a town. The difference was human. Trust, planning, and the courage to act on incomplete information. Campi Phlegrae has the finest eyes on Earth and the hardest problem on Earth, and the eyes have done their work, and the problem now belongs to us. The paper draws its wall across the early 2030s. The data keeps agreeing with the paper. The logger in the harbor keeps counting upward. And somewhere, in a room we have not yet been shown, a decision waits to be made by a person who does not yet know it will fall to them. So here is the question I cannot answer, and neither can anyone else, and that is exactly why it is the right one to end on. We can now say, with more precision than at any point in human history, when the ground beneath a city is likely to reach its breaking point. We still cannot say what we will do about it, or whether, when the moment comes, we will move in time.